Hi, my name's Doug Amos. I'm with NMI, and I'm here at the request of TVS in this inaugural presentation of an FPGA track. And I think it's great that we've got an FPGA track in verification futures now. To go over a survey that we did last year, in October last year, in fact, I'll tell you some details. And the survey was to find out what the heck people are doing with FPGAs in the UK and Ireland. And a significant part of that survey was asking people what are they doing in terms of verification of those FPGAs. And so we thought that would be something useful to share with you guys. The screen I've got up here is, if it works, there we go. That's some of you will recognize, hopefully, because this is what you were greeted with when you went on to the survey. The survey was online, and it was done in conjunction with the worthies that you see at the bottom of the screen here. And as you can see, that's like a who's who of the FPGA industry. Particularly want to highlight New Electronics here, because in conjunction with New Electronics, we've also been publishing some of the results of this survey. And today is another chance to, publicize some of the results of that survey that haven't been seen before in public. So thanks to all these people for sponsoring and helping to publicize the survey. The focus really was to test our assumptions. So, I think we all feel we know what people do with FPGAs. But I also have other assumptions. Personally, I believe that what we do with them in the UK and Ireland may not be exactly the same as maybe the mainstream. Certainly, commercial design for a handset somewhere in China may not be quite the same sort of approach as someone that's, creating an aero engine in Derby. So there's, those assumptions needed to be tested, and we need some data to do that. Once we have this, we can identify, what we're really good at here, what needs we have, and that'll help inform what we do at NMI. I'll tell you a little bit more about NMI right at the end there, but basically our job is to represent the UK and Irish electronics and systems industries, and basically, be a champion in terms of representing and observing needs. Totally member supported, it's not a government quango or anything like that, but as I said, I'll mention a little bit more about how you can find out about that at the end. So it's our job, really, to find out what you guys are doing with FPGAs. My job is to manage all the FPGA activity for NMI, and that's including networks, training, workshops, and so on. So that's why we did it. NMI members are allowed to reuse this data quite happily, as long as they put the citation of where it come from. There's my suggested citation source. It was not intended as a market share survey, so I'm not in the business of trying to find out who's using whose tools and which chips and all that sort of thing. The questions were developed with a bit of help from New Electronics, as I mentioned, but also I should mention Mental Graphics, First GDA, Aldec, and Xilinx, all of whom made good suggestions for questions and terminology to be used. It was running through the whole of October. We used SurveyMonkey to do that, and we had prize draws to help people. The prize draws were drawn completely fairly and observed by New Electronics themselves at their offices. And then we've been publicizing this ever since. One of the things that most of the supporters of the survey did was actually to publicize it, email blasts and so on, and tweets and so forth, so that we wanted to get to as wide a number of people as possible. As I mentioned, the questions were developed not totally in isolation. We came up with 23 in the end, mixed into about 5 sections. All the questions, where possible, were open-ended. People were allowed to write what they liked. I didn't want to have a whole bunch of tick boxes from which they could select, the closest answer. The trouble with open-ended questions, of course, is that they need some interpretation. But that's okay. We've got some people around here that know about FPGAs to do that. And as you can see down here, numbers of questions in these different sections. We're going to be focusing on that middle section there about verifying and debugging. Just to tell you about the responses, there was 174 people took the survey, of which 134 completed it right up to the point of giving us their details. Of course, if they didn't give us their details, they couldn't win a prize. But even the partially completed surveys were useful. People give us good answers up to the point where they have to drop out for whatever reason it was, which gives us back to, in each question, a result of around about 125 up to 159 data points for each of the questions. So let's look at some of the analysis. As I said, I'm going to be really focusing on the verification aspects, and we've only got 15 minutes, so I have to limit really what I could show you. So the first question, having said that this wasn't a market share survey, was to ask people which device they use. And it was, once again, it was an open answer, so sometimes they just gave, a vendor name. However, sometimes they write down to the device family, and very seldom give us the exact device that they used in their previous project. And as you can see here, in the UK at least, we have a three-way split really between Altera, Xilinx and the rest. And I guess that wasn't too much of a surprise. What was good to see in the top right here is that when it comes back to families, there is a rapid growth of the use of those devices which have the embedded ARM cores. Both the Zinc and the Array devices have dual A9s, as you probably know, and it's great to see an uptake of those kinds of devices already going on. And you can see, as I go through these graphs and so on, in the bottom right you can see how many responses and what kind of question it was. The top of the graph, the top of the slide is the exact wordage used for the questions that people answered. I should have mentioned that before. So, okay, great. What are you doing with these devices that you've selected? And people are allowed to give multiple answers here. Okay, so which kind of sectors and applications that these are working in. And that's why these numbers add up to somewhat more than 100%. So, as you can see here, the biggest chunks are, aerospace defense, industrial, which is kind of a catch-all, a lot of wireless and wireline, video, and so on. Somewhat less going on in the more sort of consumer-orientated things, but nevertheless there is still some. So we do see, I think this is a representation of UK electronics and Irish electronics as a whole. So the conclusion we can probably draw from this is that FPGAs are used kind of everywhere that we do design. I wanted to find out, before going over the verification, how the projects are actually running to schedule. So here this question was, asking a fairly delicate question, which is, how well do your typical projects run to schedule? As you can see here, some finish early, many run on time, but the majority are either slightly or well over schedule. And of course people are allowed not to comment because, as I said, this is a somewhat sensitive area, especially if the boss finds out. So in this case we've got a good question to answer, which is why? Why are these slightly over schedule? Is the schedule just wrong from the beginning? Or are there certain parts of the design which are taking longer than expected? And so that leads us to the next question, which was really what percentage of time in the project is given over to these different tasks? Now this was a multi-choice answer, so again we asked people to add their number up to 100%, and thankfully we're all quite good at arithmetic in our heads, and we managed to do that. And as you can see, really it's the chunks of the time are taken up with something which is almost independent of the fact it's FPGAs in use here. It's the design specification, the entry of that design in RTL, and the verification of that RTL. And in fact the verification just comes out on top as the biggest chunk of the project. So you can see well over half of the project time is independent of the fact that it's FPGAs that we're using. But then if we look on the left-hand side of this chart, you can see that big chunk of 12%, which is the in-lab debug, if you like, configuration and debug. A little bit more about timing analysis and closure. I highlight those two because we'll come back to those in a second. So between us, we are facing exactly the same problems that the ASIC and chip designers are facing, which is verification, entry of the correct design, and verifying that that design is correct. Same as everybody else making chips. As a subset of that, one of the questions we did ask is, are you working to any of these safety critical standards, such as DO254 for airborne, 26262 for automotive, or various safety standards and so on. Now, be warned that there's only 21 responses here now. So what's that saying? That's saying about 15–20% of the people that we surveyed actually are working in these kinds of areas. But I think it's key to look at that, because what we come up with is this. So those areas where verification is more important, obviously in safety critical designs that's the case, then people are spending considerably more of their project time in that area. So these two charts are really belying that belief that some still have in the ASIC world, is that FPGAs don't get verified. Simply not true. At least here in the UK and Ireland, that's for sure. they do get verified. And in fact, 2 to 3 times as long is spent in RTL verification than in lab and debug. So the old myth that FPGA guys enter the design, go in the lab and see if it works, actually it's not true. Unless you guess you're running a hobby shop or something like that. Serious people do serious verification. So the next question was, what are your challenges then? Okay, and people are allowed to select up to 3, once again from a multi-choice answer. So what are your up to 3 top challenges? And you can see here that time analysis, time enclosure, as an FPGA guy, you would understand why that would be the top challenge. Getting the chip, which is still a coarse-grained architecture, running at speed, predictably at the speed you expected, is still just about top challenge. However, look at challenge number 2. It's RTL verification. So they already see that people are spending a good chunk of their project time on verification or RTL, and yet they still see it as a challenge as well. And of course we can go back and look at some of these other things. Overlaying on this, which is our challenges, those previous results we showed you as a pie chart. Okay, so this is where we are spending our time as a percentage. Then we start to see 2 really interesting things. Those 2 areas which were consuming the most time as a proportion of the project. So that was RTL entry, if you remember, and RTL verification. Well, look at RTL entry. We don't see it so much as a challenge, but it still takes time. So maybe there's some room there for simplifying the way we do it, or maybe not using RTL, maybe using some abstracted design methods. Ditto for the design specification. Maybe there's a way of combining specification with design entry using maybe some model-based approach. But looking at column 2 again, we see the RTL verification takes time and is challenging. So here's an area clearly identified that we must do something. So going beyond that, we ask, great, what are you doing in terms of verification? How do you typically verify your designs? So you can see from this one that, once again, we gave these as multi-choice answers, and you've got that right when the other, and you can see at the far right there, is very small, then you must have got your selection right. So I'm happy with that. Yes, we do manual code reviews. We do a lot of in-lab testing. That still comes out as the top. Why? Because we can. That's the blessing and the curse of FPGAs, that you can still change things at the last minute. However, we do see simulation, particularly directed tests, okay, but some now constrained random simulation coming in as well. People taking a much more ASIC/SoC type approach to their FPGA RTL verification. The code coverage and functional coverage kind of almost spinning out of that. Good to see. Next step beyond just writing waveforms and looking at writing vectors and looking at waveforms. We're seeing use of self-checking test benches and things like this, and the functional coverage coming up as well. What we don't see, however, are these types of verification technique. So very little use of assertions, either in PSL or SVA, or equivalence checking. And so these are areas that really would help to balance that time taken versus challenge seen dichotomy that we saw on the previous graph. So some of the techniques that we've been maturing for the ASIC SoC industry and actually using for the last 5 or 10 years are completely applicable to the RTL that is put into FPGAs, especially when you consider that the scale and the complexity of FPGA designs today easily match those that we were doing in full custom and SoC and ASIC chips just 5 or so years ago. So these are the technique areas where FPGA verification needs to expand. We need to be applying these kinds of techniques, I believe, to help get that challenge that we see for FPGA verification down. So in future work, obviously I've been going around publicizing this. There's also, in new electronics, and look for further publicity around, this survey and, further analysis that we're extracting from that. You can also read about it in the NMI yearbook, as I mentioned before, just been published. It's available to non-members and members alike. Just go to our website, which is nmi.org.uk, and you can just quickly register that and download it in electronic form. We can do deeper analysis. We've got to be careful about too much correlation, because as you correlate overlapping sets of data, the overlap area becomes quite small. So we saw earlier, looking at the subset of the verification question around the safety critical standards, we ended up with just 21 data points. Too small to really change your life. So, you know, we've got to be careful of doing too much analysis and going beyond really the remit of what we're trying to do with this survey. But to certain people, NMI members in particular, I am able to supply anonymized versions of the data if further analysis that you want to do, maybe in academia. And also, you know, we'll be follow-on discussions and our own networks. For example, we ran a network just a couple of weeks ago around high-level synthesis, driven by the survey telling us that people see RTL entry as a time suck but not particularly difficult. And the last thing we want to do is actually do it again. So at regular intervals, probably in October again this year, we'll rerun a survey. Many of the questions will intentionally be identical so that we can see trend information. But, you know, there'll be some new things in there as well if you want to help us with that. But particularly if you see an email from me saying, please do our survey, go for it. Please do that for us. We're very thankful for the data that we've got. I believe 174 is a good representative set of data. Let's see if we can get that even bigger next time. So thank you very much for your time. If you'd like to ask me anything about any of this data, or maybe make some suggestions, there's my email address. I'd be very happy to hear from you. And lastly, I just want to say thank you again for TVS for allowing us to stand up and take some of this time in this inaugural track about FPGA verification. Thanks for your time.